So, as promised, in this video I'll make a quick test of the Arduino Nano's switching capabilities. How fast can the Arduino using this basic digitalWrite function switch its outputs from states from low to high. And I've written this very simple code here that will use the output A0, the analog output 0. We will digitally assign it. It's perfectly fine. I just chose this port because we used it on our EEPROM programmer as the write enable pin. And we have a somewhat critical timing for this write pulse. So it's a very simple code. We assign A0 to this constant. Then we set the pin mode as an output, and finally on our loop we say digitalWrite hello, and then just after that digitalWrite hi, without adding any delays on the code. And if we program our Arduino with that, and I'll show you on the oscilloscope screen. We have a period of 6.8 microseconds. We are way above what we need as a minimum write pulse for the EEPROM to work, for the write pulse to work. And I also plotted the frequency there that corresponds to 145 kilohertz. So that's the fastest our Arduino Nano can switch its ports using this digitalWrite functions. And as a proof of concept, I'll add here a delay, or I'll add a delay microseconds of 1 microsecond, and we'll check if that has any impact on our test. And as we see, the Arduino is resetting. There we have it, the absolute same result, 145.8 kilohertz, as expected. So we can still try and do like a 2 microsecond delay, and we can keep trying this until we see an impact. At some point we'll start to see a difference, and it's actually already there. With 2 microseconds delay, we have increased a period a little bit to 7.6 microseconds. If you want to be able to address or to switch the outputs of the Arduino faster than this, one way to do it is to address the output register of the Arduino directly, and we can do that with this port C. And port C is the register in which our analog output 0 is connected, and we write a byte to it directly. 1, 2, 3, 4, 5, 6, 7, 8. So, and then we switch it. The last bit here of this instruction corresponds to output A0. With this code, we should see the Arduino switching much faster. So let's upload it and take a look at the waveform. Well, that's surely an improvement. Let's increase our time. So we see now that our clock pulse is much faster, but it's not constant, because we have the time that Arduino takes for it to repeat the loop. So the first 2 instructions, they're really fast. We see it will switch from 0 to 1 and then from 1 to 0 very quickly, and then remain at 0 for a longer period to finally rise again. And if we just repeat this instruction here a few times, just to get a better idea of how fast we're switching. Let's just upload this code here. Now we see that this delay is between the loops is appearing at some points, but we have a better measurement, and we see 125 nanoseconds between the periods, and that corresponds to an 8 megahertz frequency, which is what we would expect because the Arduino Nano runs at 8 megahertz. So that would be a way, so directly the port manipulation through directly addressing the output register, it would be a way to get around the digitalWrite function limitation of being much slower than what we would expect while writing the code. So I hope you enjoyed this test, and see you back at the 8-bit CPU videos.